So we're going to talk about how to simplify square roots in this video. Simplifying square roots is something that pops up a lot in geometry throughout the year because we deal with a lot of formulas that have square roots in them. So it's good to know how to manipulate them and to make sure that we treat them just like we treat other numbers, and then note they follow all the same properties. So when we simplify square roots, the main property we use is this. So if you multiply two numbers under a square root, then it's actually equivalent to taking the square root of those numbers first and then multiplying them together. So this is saying that something like the square root of 2 times 3 is equal to the square root of 2 times the square root of 3. Right? And what we're going to use this property for is we can simplify the numbers under square roots. If there are numbers in a square root that have factors that are perfect squares, then we can simplify it by taking the square root of the parts that are perfect squares. So let's use this in action. So 8 here. We know that 8 is equal to the square root of 4 times 2, because 4 times 2 is 8. So I'm breaking 8 apart into 4 times 2 because now I can split up that square root. That's the same as the square root of 4 times the square root of 2. And remember, when we're taking a square root, we're asking ourselves, what number do I square to make 4? And over on the table on the right, that's why we listed these here. So we have, and we're going to refer to this table a lot, so if 2 squared is 4, then that means the square root of 4 is 2. So this square root of 4 equals exactly 2. And then the other part I cannot simplify. So really 8, the number 8, the square root of 8 is equivalent to 2 times the square root of 2. And you can see this in action over here. So if we go over to a calculator and I type in the square root of 8, then I get this decimal. And if I type in 2 times the square root of 2, I get the exact same ugly looking decimal. So those two things are equivalent to each other. So a second example here, we have square root of 6. Now, the thing about square root of 6 is one divides square root of 6, but we can't pull out a 1 because it's the same number. And then the only other number we could possibly pull out would be 2, but we know that 6 divided by 4 isn't even, so square root of 6, and we could break it into square root of 2 times the square root of 3, but neither one of those is simplified, or neither one of those can be simplified as a perfect square, so really this just cannot be simplified. So if we were dealing with this square root in some sort of formula, we would just leave it as square root of 6 and call it a day. 5 times the square root of 45. So here we have this 5 that's in front is being multiplied by the square root of 5. So really all I have to do, I'm going to ignore the 5 until the end, but I do need to simplify the square root of 45. So I have a 5 out front, and this 5 out front is just going to go along for the ride. So we have 5 times the square root of 45. And then the square root of 45, if we refer over to our perfect square table, we know that 45 is equal to, so 45 can be broken into the square root of 9 times the square root of 5, because 9 times 5 is 45. So we still have the 5 in front. And we know that the square root of 9, that makes 3 exactly. So this is 5 times 3, and then this square root of 5 cannot be further simplified, so we have 5 times 3 square root 5. And at the end here, we have this 5 times 3, so those can be multiplied together to make 15. So this is equivalent to 15 times the square root of 5. So once again, let's go ahead and check our work. So we said we had 5 square root 45, and then we said it was equal to 15 square root 5, and once again we get the same ugly decimal for both, so we know that they're equivalent. Square root of 448. So this is a really big number. I don't know the factors of square root of 448 off of the top of my head. I don't know numbers that multiply together to make 448. So what I'm going to start doing is I'm just going to look at the numbers in this table. And I'm actually going to start bigger numbers going to smaller numbers. Because if we find the largest number from this table that evenly divides 448, then we can pull that one out first and it will save us steps in the long run. So we'll just test some numbers out here. 448 divided by 100. Nope, not a whole number. 448 divided by 81. Not a whole number. 448 divided by 64. Hey, we got a whole number. So 64 evenly divides 448. And the answer is 7. So that means 64 times 7 makes 448. So we're going to split the square root of 448. This guy is going to split into the square root of 64 times the square root of 7. And then we know that that makes 8, because 8 squared is 64. And then square root of 7 cannot be further simplified. Now I'm sure what you're thinking at this point, well, what if I hadn't found the biggest number first? And that's actually okay. So you can keep that on your paper, don't erase it like I am. But let's say we had gone in the opposite direction and found the smallest numbers first. So in this case, we could have tested 4 first. 448 divided by 4. And then we get 112, right? So suppose I was breaking it down with smaller numbers first. So I would have done square root of 4, and then I was left with square root of 112. And square root of 4 is 2, and then I have, but now I still need to try to simplify square root of 112. So again, what if I start with my smallest number, right? So let's try it out and divide 112 by 4 again, and we have 28. So we have we'd already broken this into 2 square root of 112. I know it's annoying that every time I exit drawing mode, my drawing gets erased. But now we've learned that we can break 112 into the square root of 4 and the square root of 28. And you see where this is going. Square root of 4 is 2 again, so now I have 2, I already had this 1, 2, and then 2 again, and then times the square root of 28. And on the outside, 2 times 2 makes 4. So now I'm left with 4 root 28. But once again, I still have a square root that I need to simplify. And 28, this one I do know off the top of my head. I could break that into 4 and 7. And at the end, that's going to break down into a 2 and a square root 7. So I had another 2 come out front. So I already had 4 root 28, and now I get 4 times 2 again, and then that square root of 7, which now is 8 square root 7. So we got the same answer starting with the big numbers first or starting with the small numbers first. But we saved ourselves a lot of steps by checking all of these large numbers first. Because remember, the first thing we did was immediately pull out a square root of 8. And if we did it the long way, then we pulled out a 2 3 separate times. So my advice is always, you don't have to know you have to know those perfect squares, but if you just start dividing by these perfect squares when you're testing a number, then you save yourself a lot of time. Okay, so a few more examples. Now we're kind of going the reverse with some of these problems. So up here we were breaking square roots down into other things that we could square root. Now we're going to multiply radicals and then sometimes have to simplify them. So square root of 6 times square root of 10. Well, since they're both under radicals, I can actually just combine them into one radical. That's the same as square root of 6 times 10, or square root of 60. And now I have this larger number, 60, and I want to break 60 down into a simplified radical. So 60, I need to think of numbers that multiply to make 60 and also are on my perfect squares list. So I know 60 is 10 times 6, but neither 10 nor 6 is one of my perfect squares. So I believe the only number on there that I can divide 60 by is 4. So that's going to make, so 4 times 15 makes 60. And I can then test that out, or take the square root of 4, and I get 2 square root 15. Again, always a good idea to check your work. So we had 2 square root 15. So originally we had square root 60. We simplified it, or no, originally we had square root of 6 times the square root of 10. And we then said that that's equal to 2 times the square root of 15. Sure enough, same decimal for each one. So 2 square root 7 times square root of 8. So in a problem like this, it's, since square root of 8, in fact, we simplified square root of 8. That was our first example, right? So if you look up at that top example, you might remember that 8, square root of 8 can be broken into 2 square root 2. So now we have 2 square root 7 times 2 square root 2. And the way we multiply things like this is, so one thing to keep in mind is the order doesn't matter when you multiply numbers, and I could rewrite this same expression as 2 times square root 7 times square root 2, right? All of these things, the order doesn't matter when you multiply, so I can rearrange it in the way that is most convenient for me. And now we just multiply the 2 and 2 to make 4, and multiply the numbers under the radicals, and we get 4 square root 14. So on the next example, we have square root of 12 and square root of 12 times square root of 3. So in this case, I actually could break down 12 first into, that would be square root of 4 times the square root of 3. And then the square root of 4 is 2. So 2 square root 3 times square root 3. Okay, so now I can multiply these two numbers that are underneath radicals. So I have 2 square root 9. But then wait a second. 9, the square root of 9 is, that one's a whole number. That one's on our perfect squares list. So at this point, because 3 squared is 9, that makes the square root of 9 equal to 3. So now the radical is gone because we were able to perfectly square root everything. And 2 times 3 is 6. Another way to do this problem would have been to multiply them together straight away. So 12 times 3 is 36. And you see the same thing. The square root of 36 is exactly 6. That one's on our perfect square list. So 2 ways to get the same answer. Alright, and then last example, we have 3 square root 72 times 2 square root 11. So 72 times 11, if I were to multiply these first, I would have to simplify square root of 792. And that's a very large number, and I don't know the factors of that off the top of my head. So in this problem, it's better to simplify the square root of 72 first, because then we'll deal with smaller numbers to simplify at the end. So 72, again, we can go through and divide by numbers from our perfect square table. And the first one that will work is not 9. So if I'm looking at my perfect square table, well, this is the one that came to my mind. Square root of 9 times the square root of 8. And we know the square root of 9 is 3. And hey, we simplified square root of 8 already. We know that one is going to break down into 2 times the square root of 2. So we had a 3 out front, so this 3 is going to now go over here. So we have 3 times 2 times the square root of 2. 3 times 3 is 9, and 9 times 2 is 18. So we got 18 square root 2, just from that first part. So now, this new problem is 18 square root 2 times 2 square root 11. And now I just have to multiply the numbers outside. So 18 times 2 is 36. And then multiply the numbers inside. And 2 times 11 is 22. So 36 times the square root of 22 is our final answer. It also just occurred to me up here that 72 is equal to 36 times 2. So we could have broken 72 into this square root, which would then make 6 root 2. So just like we said earlier, I couldn't think of the right perfect square off the top of my head, so I just found smaller ones, and I got to where I needed to go eventually. Alright, so simplifying radicals, it's kind of tedious at first, but you get the hang of it, and it really does help us with manipulating numbers all throughout geometry class especially.